the whole compilation process for Java. How for Java you go from code to bytecode to the Java virtual machine interprets it, and then you go to binary, and how other languages go from code to binary, which is why Java is a slow language. So I basically like mapped out everything. This was a few years ago when I found it, so I just put it on there. So that's that. So if you didn't really get that part, you can go look at that. Last meeting we looked at all this stuff. So we looked at comments, which is pretty easy. We looked at basics, classes, the main method, instructions. Once we go to object-oriented programming, you'll have a better understanding of what's a class and what's a method and what's an object and all that stuff. We went over variables, but we're gonna go in depth in strings today and go over concatenation and user input. And then we did arithmetic operators and relational operators. And we'll learn logical operators and go towards conditional statements and expressions and switch case, which is basically conditional statements. And we'll hopefully get to arrays today. And we'll do some practice problems as well. Okay. So first we're gonna go over, so everyone knows the basic data types, right? You have integer, you have double, you have string, which is a class, and you have character, so char. But right now we're gonna focus on strings, and we're gonna work on user input and concatenation. So basically what concatenation is when you're combining strings. So let's say you want to print out
Wait,
two different,
so I have a
yeah,
question.
yeah,
So by putting together strings, you mean like having two separate strings, and then you like
yeah, and then
you
combining
add
them
them.
together.
Like so,
Yeah,
if there's two separate variables, all right.
yeah.
So
So
like
I'm
you can
gonna,
put stuff in between.
yeah, and then I'll show you user input, and we'll do like a mini program. So let's say I declare a string. So what you do is you do string, and since string is a class, you have to make it capital. Classes are always capital like this right here. String first name equals Bob. And you can declare another string last name equals Joe. And you can print out onto the screen, you can combine these two strings together. So you can say hello, and you do a plus sign, first name, plus sign, last name. So this will print out hello, first name, and last name. So if we run this, you'll see that it works, but we don't have, there's no spaces in between. So to fix this, we can put a space here. We can add another string in between, and we can do a space right there. So it basically just combines everything all together. That's what concatenation is. So now you can say, now you can see it's hello Bob Joe, because you combine the strings. So that's what concatenation is, basically just combining the strings together. So now one more thing. So when you're printing out an integer, right? When you're printing out an integer like int x equals 5. If you put x here and you say x plus 5, it'll do the arithmetic operation plus 5 inside this instruction, and it'll print out 10. Okay, let's say you do something like Bob, right? Bob, or first name, plus x. You can also concatenate a string and a integer together, and you'll get what you would expect, Bob 5. However, if you do first name plus x plus 5, so basically instead of adding x and 5 together, as you would expect if you do something like x plus 5, you'll get 10 here. Instead of it saying Bob and then 10, the reason is it just adds another 5 here is because you have a string in the beginning. Does that make sense?
Yes.
So here you have 10 because it sees that both of these are integers, so it just prints out 10. However, here, since the whole thing is, since it's going to print out a string, it's going to see this is a string, and it's going to concatenate this and this together. So 5, 5, it just prints out the string. So that's what concatenation is basically, just combining things together, combining strings. So now we're going to implement user input. And the thing with user input is you have to import a package. So the beautiful thing about Java is that you can easily just look up. The only thing you have to memorize is basically the syntax. So you can just look up scanner Java. So the class you use for user input is scanner. And then you can see all this documentation, and you can see what you have to import. So this is what we have to import. So you can just import that here. Scanner. So you have to import the scanner. Scanner is a class, and scanner has a bunch of methods you can use that allows you to take in values. So we'll just delete this for now. So to use the scanner class, you have to create a scanner object, right? So it shows you how you do that here. And then you have to use these different methods. Like next line, I'll show you that. So you can do scanner input equals new scanner system.in, right? And this is basically a reference variable. When we get to object-oriented programming, you'll get that in more detail, but this is a reference variable. And then if you use the dot operator, like input dot, you can access all these methods that are inside the scanner class, which we imported. So if you want to get like if you want the user to input a string, you can do input.next line. Is the next line? You can do string x equals input.next line. And when the user inputs the next line, it'll store it in this variable x. So you can look up scanner Java methods, right? There are many methods in the scanner class you can use. So you can go here, you can look at the documentation, and you have all these different methods you can use. You can use next big integer, where it scans the next token of the input as the big integer. This is the one you're using, next line. So what it does is it advances the scanner past the current line and returns the input that was skipped. So you have all these different methods you can access and you can use. So now we're basically so what we're gonna do is we're gonna ask the user to input their name, and we're gonna just say hello and their name. So we can say string name equals input.nextLine, and then you can print out to the screen name plus, we'll do hello name. Wait, first we should say input your name. So when it says input your name, I can say a name, and it'll just print out hello Bill. But we should put a space there because it just concatenates. And it says hello Bill. So does that make sense?
Yes.
Yeah. So this, I had to import a package. This is a package. I'll explain that later, what a package is. but this is a package, and we imported this package, and in this package there's this class called scanner, and in this scanner class you can use these methods like dot next line, or there's dot next int, and there's many other different methods, or dot has next, and you can use those methods when you declare this reference variable. Like, so this is a class, day2 is my class, and main is a method. So in this class scanner, there's different methods, and there's a method called next line, and we're accessing that method, we're calling that method, and it basically just, this method asks for user input, it asks for a string, and we input the string, and it stores it in this variable name, and we do hello plus name. That's basically how it works. So we can enhance this a bit. We can say, we can call this string first name. And then we can do string last name equals input dot next line. So you can say input your first name, right? And then you can say input your last name. And if you do this, so we print out onto the screen, input your first name, and the program is looking for the user's next line, and you input the first name, and then after that happens, input your last name, and it looks for the next line, and then it prints out first name plus last name. So we can say Bob, and then Bill. And then again, we should put that space in the middle because it just concatenates everything together. Oh. So that's like a basic program. That's like a basic example problem, because last meeting I didn't do that many example problems, so this is one. So if you noticed how whenever I run this program, and when I try to input my first name, like Bob, it does it on the next line, and it doesn't do it here. So in order to make it do it right on the same line, you have to remove the ln. So what print line does, instead of print, so what print line it does is it prints out this value and it goes on to the next line. But if you just do print, it stays on the same line. So if you remove print line, that's what it would do. So it asks us, Bob, Bill. So yeah. Does anyone have any questions about that?
Yes.
Yeah,
What about like this code right here that we're using to print?
Yeah.
Why can't we reply to it, like put an input and then it takes it and prints it? Well, the stuff that we did on Friday didn't do that.
Oh, because, what do you mean? You mean
Because the stuff on Friday didn't ask for your input. It was just
Yeah.
all done through the code.
Oh, okay.
This one, there's a function asking for your input.
Yeah.
Okay.
Yeah. So yeah, I imported this scanner class, which has a scanner. I imported this package, which has the scanner class, and I'm using these different methods in order to use this program. And you'll get how all that works when you go into object-oriented programming. So yeah, that's concatenation. So what did we want to go over next? So yeah, going into this meeting, I forgot how to use scanner, so you can easily just look it up, and you can look up the methods. The only thing you have to memorize in Java is the syntax. Everything else is online. So yeah.
Oh my god, Ron.
I mean, Is it not facts?
Oh my god.
That's the point. The only point of Java, learning Java, is the syntax. Everything else is online.
Okay. All right.
I'm making a Android application currently, and 3/4 of my code is copy pasting from like Stack Overflow, and it's being able to integrate that. That's like, I'm being honest. That's literally Java. Unless you're doing Java competitions where you can't use the internet, then you should memorize all this stuff.
Yeah.
Okay.
Mm.
Logical operators. Okay. So I'll delete this. So in day one, we went over these different operators, right? Oh, I deleted the logical operators. Okay, that's fine. Okay, so I'll copy paste this. So these were the basic operators that you should know for any Java program. But then one thing that I briefly went over but didn't really go in depth was logical operators. So I'll just type that up, and then we can go into conditionals, which is very important. So you have this, not, and, or. Okay. So what not is basically is it switches the condition. So if you say something like Boolean x equals true, and then you say Boolean y equals not x, right? Then y is false. It just switches it, basically. So this is so basically, if you read this, it says Boolean x equals true, but Boolean y is not true, which is false. So Boolean y is false. So that's what this exclamation point is used for. It's used for not. And with and, okay, so now we'll go into conditions. So does everyone kind of get an idea what if else statements are used for?
Yes.
If this
Yes.
condition is true, then run whatever's in this curly braces. If that's not true, then do else. And then you also have else if. I'll go over that soon. So let's say I say x is, we'll do, okay, we'll start from here. I'll declare a few integers. So int a equals 8, int b equals 10, int c equals 14. So let's say we say if a is less than b, then we print out onto the screen yes, a is less than b. However, if a is not less than b, it'll print out onto the screen whatever's in this else statement. The condition was not true. So before printing this out, we can tell that yes, 8 is less than 10, so it's going to run this, and it's not going to run this. This is a conditional expression, so this is one block. So it's going to check, it's going to go in order. It's first going to check if this is true, and if that's true, it's going to print this and just skip to the bottom. Print this out. Yes, a is less than b, because this is true. But if this is not true, if we do something like a is greater than b, and I already taught you guys these expressions. These are relational operators all here. So if this is that, it's going to say the condition was not true because a is not less than b. So yeah. And so that's greater than and equal to. That's greater than and less than. We can also do equal to. So if a is equal to b, You have to know the difference between a single equal sign and a double equal sign. A single equal sign is when you're setting a value like we do here and here. But a double equal sign is when you're comparing two values together. So you're comparing A and B, you're not setting any value. So here you're seeing if A is equal to B. And we already know A is not equal to B. So the condition wasn't true, and it's going to print out, it's going to execute whatever's in this else block. So yeah, and then the last one is if A is not equal to B. And A is not equal to B. 8 is not equal to 10, so this is gonna be true. It's not. A is not equal to B. So do you guys understand what's the difference between this, the exclamation point equal sign, and like the double equal sign, and then the single equal sign? Do you guys get all that?
Yeah.
Okay. So yeah, the double equal sign and this exclamation point equal sign, they're opposites basically. This is seeing if it's equal to, and this is seeing if it's not equal to. And only if whatever's in this bracket, whatever's in these bracket things is true, it'll run whatever's inside this block. So that's how conditionals, that's a conditional expression. That's if, else, and you also have else if. I'll do that soon. So these are relational operators where you have greater than, you have greater than equal to, you have less than equal to, you have equal to, you have not equal to. So now I'll do logical operators. So logical operators allows you to see if they're multiple. So when you have a brackets, you can see if multiple expressions are true. So let's say if A is greater than B and B is greater than C. We'll just print out true. So this basically says if A is greater than B, which is already false, right? And this is if B is greater than C, which is also false. Let's say B is less than C. So this is true. This statement right here is true. 10 is less than 14. But this statement is false. So this thing won't run because both statements are because both statements need to be true in order for this to run. That's what logical operators are. So this will only run if this and this is true. So if we run this, the condition was not true because this is false and this is true. But in order for this to run, both of these need to be true because we put this and. However, if we want just one of them to be true, we put this or. So this is saying if this is true or this is true, run. We know this is false, but this is true. And you only need one of them to be true because it's an or statement or logical operator, so it'll run. So it'll be true. So does that make sense, the difference between like or and and? Yeah, so
Father.
yeah, so that. And so the last one, last logical operator is this not. Right, so you put that not there when you're trying to switch the condition, you switch the boolean you get from this. So from this we know you get true because this statement is false, but this statement is true, so that works because it's an or statement. So this whole statement is true, and this negation, this not, makes it false, so it switches it, and this won't print out. Because you get false from this whole thing. So you can put this not here at the beginning of anything to basically switch the Boolean to the other condition, to the other Boolean. Okay. So does that make sense? Like how you use each one of these?
Yes, sir.
Okay. I'll do a quick example. So let's do a quick example using scanner and stuff. Scanner input equals new scanner system dot in. Right, so we declared our thing there. So let's make a program that you get the temperature and you see if it's hot, cold, or very cold or like very hot. Right? Let's try that. So let's say we say okay, input the temperature, and let's have it on the same line. So we'll do print, and then input dot next, and this time let's do next int, because it's gonna ask for a because we're gonna input a number for the temperature. So int temperature equals that. So we're gonna print out on the screen, input the temperature, and it's gonna ask for the next integer. So we're gonna put in an integer and it's gonna store it in this variable temperature. And once we store it in this variable temperature, we have this variable, and now we can do a bunch of things with it. So we can do if temperature is greater than 100. All right, if it's greater than 100, we can say the temperature is really hot, right? So this is where else if comes into play. So else if allows you to put multiple conditions inside the expression. Instead of going from if to else, we can do if, and then we can do else if to have multiple expressions. So in this statement, we can ask, so if temperature is greater than 100, it prints out it's really hot. However, if temperature is greater than or equal to 70 and temperature is less than or equal to 100, we could say the temperature is hot. So it'll go in order. It'll check if temperature is greater than 100, it'll say the temperature is really hot. And if that's not true, it'll go on to the next condition. Else if temperature is greater than or equal to 70 and temperature is less than or equal to 100. And it'll say this. And then we can do another one, else if temperature is greater than or equal to 50 and temperature is less than or equal less than 70. The temperature is normal. Although 50 degrees isn't really normal, but yes. And then we can do else the temperature is cold. So yeah. So I basically just set up a quick conditional. This is an example. So you go through here. So you get the temperature, right? And you can compare it in these different conditional. So you can see if the temperature is greater than 100, it'll print this out. If it's greater than 70 and less than 100, or greater than or equal to 70 and less than equal to 100, it'll print this out. And both of these have to be true because we put this and here. It can't just be one true and one false. They both have to be true. And here, same thing. If it's greater than or equal to 50 and less than 70, it's normal. And if all that's not true, we know it's below 50. So we did else the temperature is cold. So now we can test this program out. So we input the temperature. Let's test out if the temperature is 102 degrees. The temperature is really hot, so it prints out the temperature is really hot. Try again. Input the temperature. Let's say we say it's 46 degrees, right? The temperature is cold because it went through here. It's not greater than 100. It's not in between 70 and 100. It's not in between 50 and 70. It's less than 50, so it prints out this else. So now let's say it's 80 degrees. The temperature is hot because it sees that this is true and it prints this out. So that's a quick, good example for conditionals and logical operators, relational operators, and all that. So does that make sense? How I did this quick program? Yeah. Okay. So does anyone have any questions about conditions and stuff? Or does anyone want like another example problem? Okay. So now we'll go over, so we did logical operators. We'll do conditional statements and expressions. And the more you use logical operators, arithmetic operators, relational operators, conditional statements, the more you'll get used to it and you'll know what each one of them is. So I'll have a document of a bunch of example problems maybe, and I'll post it.
Wait.
Yeah.
Didn't we just technically go over conditional statements with the if?
Yeah, we just did.
Right.
But I was just saying,
No,
like,
I think I missed.
yeah, the more you guys practice with this, the more it'll be like easier for you guys.
Okay.
Okay, so switch case. So we'll do switch case. Okay, so you won't. The thing with switch case statement is you won't. It's basically a conditional statement. So we'll keep that. That's fine. Okay, so a switch statement is basically a conditional statement, which is used to like switch between the values of one thing. So let's say I declare an integer, right? A equals 30. We do switch A case 30. Oh. And then let me just quickly type this out and I'll explain it. Case 40. Default. Okay, so This is a switch case expression. So you can do the same exact thing in a conditional expression. However, this is just easier in some cases. You'll basically never use this. Only in very rare occasions you'll use this. You'll mainly just use this. However, I'll just go over this. So basically what this
I'm a little confused there. That was kind of vague because you kept saying this. Which one is rare and which one is?
Oh yeah, this is rare. You'll never use. You won't use this that much.
Okay.
Because you can do this in a basic if-else statement.
All right.
So what it does is you put this switch keyword here, and you put in the value 30, right? A equals 30. And case, it just looks at these different cases. So if it's 30, it'll print this out and break. Break just means it'll just break out of the switch case statement. If it's 40, it'll print this out and break. And default is basically the else. So default is what's going to happen if all these are not true. So it's basically like an easier way kind of doing this if it's like a simple if-else statement, a simple conditional expression. You can use a switch statement. You won't use it that much. I just want to quickly go over it. Yeah, so you have, I'll just say it again. So you have switch and you put a equals 30, or you can put any value, you can put 40. And it just checks these different cases. These are more like else ifs in conditional statements. So it checks if a is 30, it checks if a is 40, and if it's not either of those, it'll print out the default. And this case 30 is basically seeing if a is equal to 30. And you put this colon here, and you just do whatever you need to do in here. And break just means it just breaks out of this condition. If you don't put break, it's going to check the other values.
So Chandra wants you to go over everything in the last 45 minutes.
Okay, I'll do it at the end. Okay. So was this confusing? Does anyone want me to go over switch statements again?
No.
Or is it like you just kind of know what it is, but this is the main thing. You have to get this for sure.
Okay, have you used switch statements before, like while coding the robot?
No, never when coding the robot. I've used it on some personal things. It's just like easier kind of for some cases if you're just comparing some values like this. Instead of using an if statement saying if a is, and you use the double equals sign, if a is equal to 30, do this, else if a is equal to 40, do this. You can just do case 30, case 40, default for the else. It's just like a different way. But this is the main thing you have to know. Okay, let's see, what was the, okay, so the last thing was arrays. So we'll do, okay. I'll go over arrays today, and we'll go into depth with arrays in the next meeting. So basically, an arrays, I'll just type out some definitions. So you have arrays, right? And we're gonna do single dimension arrays. We'll probably not do multi-dimension arrays in this because you won't use it that much. Okay, so an array is basically a sequence of variables that are stored next to each other. And you can, so it's basically creating more than one variable that have the same data type and are of, and then we'll say, and the array has a fixed number of values. So those are the main things you have to know about arrays. and I'll show you some examples. So to create an array, so let's say you had to create like, I don't know, like 50 different variables, right? And all these variables are somehow connected in some way. They all share the same data type and they somehow share the same property. Instead of saying like int age 1 equals 3, int age 2 equals 6, int age 3 equals 19, and just declaring 50 different variables like that, you can create an array and put them all in one array. So you can create like an int array. So this is the syntax for an array. So you do int for the data type of all the different values in the array, and you put these square brackets, which represents an array. You do int array, and then zoom in. How do I zoom in? I don't really know how to zoom in. Parents. Oh, okay, there we go. Okay, is that good? Yeah, that should be good. Okay. Okay, yeah, so this is how you declare this. Here you're declaring an array. You didn't set any values, so you just do int, and you do these square brackets array. If you remove these square brackets, you basically just declare it an integer variable. But these square brackets tells Java that we are declaring an array. And then to actually define the array, or to create, or to set the number of values in the array, you do array equals new int, and you set how many values are going to be in there. You can do 50 or 40, we'll just do like 10. Right. So here you're declaring the array, and the name of the array is array. And here you're setting the array to 10 empty slots. Right now they're all empty. You can do this all in one line. You can do this. That's the same thing. You can do it all in one line, or you can declare it somewhere and do this later. Okay. So how you set values to an array is, so basically what we did here is we created 10 different variables and we stored it in this array. And all these 10 variables are of integers. And all of these values are, all these different integer variables that are stored in this array have a default value of 0 until we change the value. So to change the value, we would do something like array, and what you put in these brackets is something called an index. You put array and then you do 0 equals 40. So what this is in the array, the first index. In Java, you have to remember you go from 0 to 1. So you do 0, 1, 2, 3. It starts from 0. So to access the first array, to access the first variable in the array, it's array, and then in these brackets you do 0, and you set it to a value of 40. And then the next variable in the array would be array 1, and you can set that to like 50. So you can keep doing that, and you can go all the way up to array, the 9th index, the variable that has the index of 9, set that to something else. And this is the 10th variable, because you start from 0. This is the 10th variable. So yeah, so that's a basic overview of arrays. I'll do like a good example now. So let's say you had a bunch of names of dogs, right? And let's say you had like 20 different dogs, and instead of declaring a variable for each dog and its name, you just create an array. So you can say array dogs, array of string dogs equals new string. And we know the array has a fixed number of values. You can't change this. You can only change it here. So here we created an array dogs, and we'll store 20 different variables, all with unique names, but are all string values in this array. So now we can declare the variables for each dog. So we can say dogs. The first dog has a name of Bob. The second dog, which has an index of 1, has a name of Joe. And you can keep doing that. We'll set this to 5 for now, because I'm not going to declare all 5 or all 20. So dogs 2 equals Bill. Dogs 3 equals Joe or bro.
Yeah, you could do Rover too. If you...
Oh, Rover, yes. Rover dogs 4 equals Jake. Okay. So we created an array of dogs of 5 values, and these are all the 5 values, 1, 2, 3, 4, 5. The 5th value has an index of 4 because you start from 0. And now in this array, which are all connected, which is a sequence of variables that are stored next to each other, they all have the same data type, they're all strings, and its fixed value is 5. So yeah, that's how you can store variables easily in an array, and then you can print out, dogs, the 1, and it will just print out, oh, let's delete this stuff. Or we can comment this out. Okay. Okay, so yeah, it prints out Joe. So this is a more efficient way for you to store all your variables if they all share like the same property, if they're all like dogs or if they're all strings, you can put them in an array and you can just access each one. Instead of declaring 5 different variables, you can do it this way. And it's just easier and more efficient. So arrays are, so there's a different way you can declare an array. So there's this way, you can declare an array this way and individually set the values, or you can declare the array, let's say int age equals, and use these curly braces, and you can straight up put all your information all in one line. You can do 17, 18, 56, 79, 79, 79, and 40, something like that, right? So here you're declaring an array, age, and you set the value of each variable. Each one of these are its own variable. 1, 2, 3, 4, 5, right? So we basically did all of this in one line right here. We could have declared this array like this and individually set it like this, or we did this.
So you're
Set it
creating a
all in
list
one line.
and putting it inside age.
What?
So you're basically creating a list and then putting it inside age.
Yeah, I created an array. Lists are different. We'll do that next time.
All right.
Yeah.
Wait,
Um,
so what's the difference? Is it like a little different? Or like,
yeah, so array lists are basically, so for arrays, you have a fixed number of values and you have indexes and you set each value to an index in its array. However, array lists, there's no set value. You can keep
oh,
adding
okay.
values. You can use like, there's different methods you can use. You can do dot add or dot set. And if you do dot add, you can keep adding as many values as you want in an array list. So if I try to add more values, if I try to do dogs 5 equals George, and if I try to run the program, it'll give me an error because we set the array to a fixed value of 5. But the
Hmm.
thing with array lists, which are different, is you can add as many values as you want.
Oh, okay.
So yeah. So we did age, and then let's say we want to print out this second age. You would do age, and you would do 1 because 1 is actually the second value
Yeah.
because it starts from
So
0, 1.
0, 1, 2, 3. So it's gonna
Yeah.
print out 18.
Yeah.
All right.
So 18. So yeah, so this 17 would be ages brackets 0. This would be ages bracket 1, ages bracket 2, 3, 4. So that's how that works. And if you look up different things you can do with arrays, there are many different things you can do with arrays. You can like you can print out if you do age dot, you can see these different things you could do with arrays, right? And one of the things you use very often is length. So if you do age.length, it prints out to the screen the number of values you have in your array. It's especially useful when you're doing loops and stuff. So yes, we have 1, 2, 3, 4, 5. We have 5 values in the array. And if you do age.length, it gives you the number of values in your array.
What's the limit?
The limit?
Yeah,
What do you mean?
like the limit to the array.
This array? So right now the
Yeah.
limit is 5. So if I try
Yeah.
to,
Wait. So could I continue on like infinity, or is it like
I mean, if
certain?
I go into this declaration statement and start adding more,
Yeah, that's what I mean.
yeah, you can do that. However, outside the declaration, if you try to do ages,
Yeah, it's not
age,
gonna work.
and then you do like 6 equals something, and then you try to run it, it's not going to work because you already set the value to 5 values here.
Okay.
So that's not going to work. So yeah, that's age.length, and then we can also print out dogs.length, and it prints out the length of the number of values in there, and that's also 5. Yeah. So this length thing is especially useful when you're doing loops, which we'll do next meeting, and just looping through an array. So you can go through each value and you can print it out. So right now, instead of doing this, if I want to print out each one of these values, I would have to have 5 different lines doing dogs 1, dogs 2, dogs 3. But in a loop, I can set the condition to the length of the array and cycle through each value and print it out onto the screen all in one line. So we'll do that next meeting. But yeah,
Could
so
you
that's
show us
pretty,
Could you
yeah,
show a quick example?
quick example of loops.
Yes.
I'll do that next meeting. I'll teach you
Oh.
while loops, for loops,
All right.
probably enhanced loops, and yeah. But yeah, that's basically what a single dimension array is. There's also multi-dimensions, which we may do, but not really important.